Hello. Sorry to be late by 2 minutes. Any questions so far?
Yeah, one question.
Yes.
What's the day that the final product is due on?
Okay, let me check the calendar. Okay.
Okay.
Let me check the calendar.
Okay.
So basically, the last week, this one is week 15, right?
Mhm.
Next week is week 16. So Saturday will be 29th, and then Sunday is 30th. So the final due would be here 11:59
Okay.
p.m. of the Sunday night. Okay, so before the midnight of the Sunday night of the 30th. I usually would be required by the university to submit the report on Tuesday morning 8 a.m. 8 a.m. Central Time. So actually it's 6 a.m. Pacific Time. So usually I don't take anything here. So I use this Monday to tabulate the final score. So I actually request students to submit before the midnight of the Sunday night. Okay, then I have 1 day to tabulate the whole every student. There are 35 students, and I need to calculate their total, and also need to curve for the whole school class if the curving is necessary. Okay.
All right.
So the due time, I mean, final due time is 11:59 p.m. of Central Time. Okay, Central Time on Sunday 30th.
All right.
Okay,
Thank you.
definitely due time. So if you pass the midnight, become May 1st. Sorry, not going to accept it. Okay,
Okay.
not going to be counted. Any other question? Okay. Any other question or any question about homework or anything? No? No, today we are week 15. We will be on virtual machine. Okay. So virtual machine. So here we need to talk about the compiler strategy. Okay. So virtual machine, what is the purpose of virtual machine? That's the first thing we need to understand. Okay. And you do have the Python language. Okay. You compile to using Lexer to tokenize and become token string. And then go into parser. Parser's job is to generate, assembly or executable code or certain kind of bytecode that can be fed into the virtual machine. Okay, so parser's output can be different kinds of the things. Okay, and using virtual machine is one of them. It's only one of them. And the advantage of using virtual machine is this virtual machine actually is not executable code. It is not assembly. So it actually is machine independent. It also is OS independent, platform independent. So because it's platform independent, so your bytecode that you generated on a certain machine, say we're using Windows to generate it, or you're using Mac to generate it, or you use Linux to generate it, is the same code. It's the same code. But the virtual machine will be written in different machine or different OS. So there may be a virtual machine on Mac OS. There is a virtual machine on Windows. These virtual machines are different, but their input is the same. Okay, the input is the same. So when you install your Python on Mac OS, there's a certain version you download from python.org. And then they come with the virtual machine of that specific type, okay? A specific type. And then you download a Windows version. Windows version has a different virtual machine. So different platform has different virtual machine, but the bytecode is the same. So your bytecode compile in one machine, one window, or one OS can always be used in other OS. Okay, so you become platform independent. So actually, before we compile to the run on the virtual machine, certain bytecode is actually good. That is actually platform independent. So you compile on one machine on one OS can always be used in other ones. So this one is the .pyc file, pre-compiled. This C means compiled. Pre-compiled Python code. Okay. So that is the pre-compiled Python code. And that is the code that actually been a platform independent. So you can try to search internet for PYC, okay, pre-compiled Python bytecode. Search this in the internet, okay. So there's a compile module, it generate bytecode, PYC, okay. And PYC is a pre-compiled one. So you can actually have a library of certain the PYC library with many modules that pre-compiled there. This is similar to Java. When you do Java's package, okay, if you prepare a Java's package, it would be similar to the PYC file, okay? And Java has the classes. Java's classes is similar to PYC file, okay? And PYC file can be directly copied to different machine, and then those modules can be used. So many companies, when they really use it for the commercial product, they usually is put into the precompiled format. Okay, they put into the precompiled format. They don't give you the source code. They usually put it in the precompiled format. Okay, so right here we have introduction to Python bytecode. Okay, so you can look at it. Okay, that's the topic that we have today. Is this precompiled code? Okay, and we actually also put into the Python virtual machine. So Python virtual machine do have a repeat loop. Okay, read, evaluate, print, and loop back. Okay, this is a repeat format. And loop the Python repeat. Okay, read, evaluate, print, loop is the interpreter that you see on the Python console. Okay, and then you take your Python input and then run on the virtual machine. Okay, so you need to understand the virtual machine model. Okay, so Python is a interpreted language. Okay, so basically the interpreter will convert it to virtual machine bytecode and then run on the virtual machine. Okay. Okay, so this is the chart. Your source code go into compiler and compile to bytecode, and then some other bytecode may come from the library module, and then they will be imported to your code and then run on a virtual machine. Okay. So you got to understand the format of the virtual machine. Okay, so here, when you actually have a function, define AB, add AB, okay, a function AB that will return A plus B, okay? So after you send this one to the interpreter, Then add is a function, and add is also an object. Add also have local variables. So add objects call underline call that underline that code co.code. Okay. This one will be is bytecode. It will show you the bytecode that actually this is. Okay, so B is binary, okay, binary format. And then you actually have a 0, has a 1, has a 17, has a OOS, has a OO. Okay, these are actually the bytecode. So this bytecode, if you check it, okay, if you actually convert it to list, then it's 124.0.124, 123.0.83.0, okay? So that is the bytecode's number. Okay. So here you can import disassembly, okay? DIS is disassembly unit, okay? And then you disassembly this add function. And then you generate low fast binary add and return value. This means that you load A with 0, load B with 1, and then you actually perform the addition on the two registers and then return the value. And this is the bytecode's operation. So this is a low fast binary and return value. These are the virtual machines code instruction. Okay, these are the virtual machines instruction. And after disassembly, you convert it back to this text format. Okay. So disassembly means that it convert a binary code of the bytecode back to the text format or the virtual machines assembly format. Okay, that's the purpose. It's coming back to here. Okay, so it's actually similar to assembly language, but it's not really machines assembly language. It's actually a universal format for the Python language. Okay, it's actually a bytecode for the Python language. Okay. Okay, so this one, if you add 5, 7, okay, and then you disassembly them, it will become like this. Okay. This function with the print function, it would be like this. Okay, and then actually you can put this thing into a dictionary format, instructions and numbers. So the two numbers are the two variables, okay, A and B's value. And then instruction are these, okay. And this whole thing, actually, there's a simple interpreter. They will run this AG, okay, it's actually assembly Python interpreter. This one will load your dictionary format, okay, and run it. This one's just to show you how the Python virtual machine work, okay. So Python virtual machine can be written in C language, but it will run similar to this interpreter format, okay. So your load fast function, binary add function, print value function will all get executed by this interpreter. And remember that your real interpreter is not like this. This one is just to show you the functionality of this interpreter. Okay. So you have interpreter and load your execution bytecode to the interpreter and you run it. Okay, you run it. So this one is to use the interpreter to run your bytecode. So you convert your Python code to bytecode and then get run by the interpreter. Okay. Remember, this interpreter is a experimental one. It's not a real one that you have. Okay. And you run and get a result of 12. Okay. So that's that. And then they are stacked. They are different executions. So the code stack will actually, when you have different code frame for different function, they will have one data stack and one block stack, okay? And then storing your variables and your calling structures, okay? Domains, your domains of the variable, local variables, okay? So that's interpreter stack. So your interpreter actually run on the code stack and the local variables, okay? And that's the stack. So Python virtual machine bytecode here, you can also use a CPython. CPython is a Python written in C language, so it's actually faster, okay? The only difference from the normal Python is actually just be faster, okay? So usually people like to write a CPython version, okay? Okay, whatever, you can look at that, this one. It is a Python library reference. And these are the every single assembly code for the virtual machine. Okay, these are all the bytecodes that we talk about. These are all the bytecode that we talk about. Okay. Every single statement of the bytecode is in this directory, in this website. Okay. Okay, so Python is a dynamic type language. Okay. Python language is dynamic type language because whatever value of type is determined based on your code frame, okay, your local conditions. It's not by pre-compiled one. So it's a dynamic type of language. Okay, so the AB put percentage. This one can be integer, can be float, or can be even be string. Okay. And string, okay, so when you have a string, it actually, the first one before the percentage is actually the format string. It takes the printf format in Java or C++. So here percentage S is a string. This string will be replacing this percentage S when it operated by the percentage sign. Okay, so you print out this mod function, modulus function will perform as hello Python. Okay, so this percentage actually have to depend on your runtime type to determine what operation it is. Okay, if it's 7 and 4, it will be 7 modulus by 4. If it's a strings, then it will be print formatted string versus the string to replace the percentage S. Okay, contain string and format string. Okay, you'll be running and get the hello Python. Okay, and these are the concept of dynamic type language. You don't know about the type until you run it. Okay, so the AB can be integer, can be 14-point number, can also be string. When string, this plus sign will become concatenation instead of addition. Okay, so it have the compiler, the interpreter have to figure out the type until you run it. Okay, so right here we have addition, this, okay, and then we disassembly and print the code. Okay. So the AG interpreter is a interpreter written in Python format, okay? And we have another one called Byron. Byron is a more advanced interpreter, better than the AG version, okay? So here we will go through the Byron, okay? Byron is developed by another person, okay? Okay, anyway, that's Python interpreter. Byron is another interpreter, just like the execution Java virtual machine. Okay, it's similar to that. So it's written in C language, compiled in C language, but actually it's a Python interpreter. Okay, so it's a Byron. Byron is an interpreter. So building an interpreter. Okay. So here talking about the machine code and how the interpreter will run it. Okay, so basically, it's talking about these different things. The executable dictionary. Okay, is an execution. It actually is a dictionary, and including instruction and numbers. And then we'll have a state machine coming with the Byron. Okay. And you run this different low value, whatever, according to the number, and then, okay, so low the value, you push the data to the stack, okay, print answer, you pop out the answer and print it, okay. At two value, you will actually pop out from the stack for two value, and then take the sum, and then put the sum back to the stack, okay. So these are other functions for the interpreter when we have the interpreter as a class. Okay. So there's a run code. Run code will load the dictionary and then run it step by step. Okay. So that actually is the basic structure for the interpreter. They have a run code version that would run whatever executable code in dictionary format. Okay. Okay, this is pretty much the idea of the. So this one, we have a function s, a equals 1, b equals 2 printed, okay? And this one will be interpreted into a dictionary like this. And this dictionary will be fed into the interpreter. Okay, interpreter will take it to run it, okay? So that's the structure and the idea of the virtual machine, okay? And you will load the data and run it and get the result 3, okay? So that's called Byron, okay? And real Python bytecode, okay? So here we get into more detail and get more function, including the if statement and else statement. So that one, with the if statement, we'll get such a binary code, and you can list it as the decimal string, okay, decimal list. And then these are the assembly code, the Python assembly code that you will fed into the Byron, okay? And then you can check each operand name and, okay, these are, you can look at that, but this operand name is array, it actually is your code, okay? Your code right here, according to the index, you can get each individual one, okay? The operand name 100, so you see a 100, you see a 100 in here. So this 100 is a operand, and the operand's name is actually called load constant, okay? And there are 125 in there. So 125, this 125. This one is another operand that is store fetched, okay? So they are different low fast, store fast. These are the assembly-like language, okay? So you load the 3 to the register 1 and you store register 0 to X. Okay, you load your S to register 0 and then load the constant 5 to register 2 and compare the operand that's then and jump if false to 22. So if true, you go into here. If false, you jump to 22. Okay. So that's the if statement. So you'll be wrong in that. And then there's a loop. You can also actually see the loop when the loop will be assembled to such a format. Okay. Will be interpreted in such a format. So we know about conditional statement, you'll be in this format, loop will be in this format. Okay, so whatever loop or instruction or if statement, you will get the executable call. Okay, and call friend is the stack for each function level. So here we talk about when you had function calling function. Okay, you create the block stack and the data stack. Okay, for the bar, for the full, for the main function. Okay. Okay, anyway, so that's actually just introduced when the if statement, loop, and function, they all be assembled to some assembly in Python format, and then PyRun will run it. Okay, so now we have a virtual machine class that included in the call friend and run call function. Okay, it's a so the whole virtual machine now is in a class. It's called virtual machine.py. Okay, and then your object and different code will be assembled to it. Okay, so here are detailed description for the virtual machine class. Okay, and there is a dispatch. You will actually run your code in this one. Okay, and then there's a block class. Okay, so basically, these different classes are different interpreter of different complexity. Okay, from very simple to something like handle the loop and if statement, and then something very close to the real virtual machine. Okay, so this chapter are primarily on the description of the virtual machine. Okay, so in a way, if you have a new language, you can translate a new language into a certain Python virtual machine model. Okay, then your compilation to the new language will be able to run on a Python virtual machine. And this concept is similar to the Java virtual machine. So Java virtual machine do have more than 200 different languages. So Java virtual machine languages. There are more than 200 Java virtual language. There are 14 very popular ones. Okay, 14 very popular ones, including the JSON. Okay, JSON is a Java version of Python. Okay, it runs on Java virtual machine. It's a Python running on Java machine. That's also possible. Scala, Kotlin, Java, Groovy, Clojure. Okay, these are different languages, but they do run on Java virtual machine. Okay, they don't have their own interpreter. They use a Java virtual machine as their backend. Same thing for Python virtual machine. Okay, some language you can compile to Python virtual machine as well. Okay. So you can see Python virtual machine languages. Okay. It supports C, C++, Fortran languages. Okay, there are some languages that can run on Python virtual machine. Okay. Okay, anyway. So this one is about the back end when you try to interpret the data into virtual machine, what should they be? Okay. So there are instructions, different instructions that you can realize the language you have. Okay. These are back end. And there are some design trick you need to avoid. Okay. Okay, anyway, Byron is a compact Python interpreter. That's easy to understand. So the purpose of this chapter is to understand the Python interpreter. Okay. But if you really want to have a Python virtual machine that run fast, you should run CPython. Okay. The Byron is just for educational purpose. The real powerful virtual machine is CPython. Okay. Faster. Okay, so this lecture just to talk about this virtual machine, and there is XPython. Okay, XPython is another Python that based on CPython's bytecode. Okay, and you can download to run it to understand. So there's a XPython 1.5. Okay, you can download it. You download it and then install it. Okay, this one is when I install it. Okay. And then this is your language. You actually dash v a.python. So this a.python being called by the Python. Okay. And dash v will show you the virtual machine code. Okay. And then after you run it, you get this. The virtual machine code is like this. Okay. So Python dash v a.py, you get the machine code. Okay. Any questions so far? Any questions so far? So we go through several versions of interpreters from very simple to here more complicated, but the goal is the same, is to convert your Python code to the virtual machine code. And you dash v, you dump the virtual machine code. You can also run it without, if you want to run it without dash v, then it's loading the Python code and run it. Okay. When you say dash v, it will show you the virtual machine code. Okay. Okay, there is a GCD Python, and then this is the machine code for the GCD. Okay, I run it on SPython. Okay, and that's it. Any question for this week?
Yeah, what interpreter do you recommend using for Python?
Interpreter in terms of speed, we actually would use a CPython. Okay, if you care about speed. If you don't care about speed and just do regular run, you use a Python, that would be good enough. Python from python.org, that would be good enough. So right now I'm using this one most of the time. Only when I want to show the virtual machine and make it run faster, I will try the CPython version. Okay.
Okay.
And then there is also the, what's that? The notebook, okay? IPython for notebook, okay? I means iterative. So that's one is not fast, but just like you can actually do interactive with the interpreter better, okay? So my son won't like to use it because you can dump to the HTML right away. And then you can show on the website. But for me, I don't like it because it's too slow. Okay. It actually too slow. So depend on your purpose. And usually I just run the generic Python because we get the newest tempo in something. Okay. The newest version of Python is there. But it's not the fattest one. It's not. But the version doesn't matter too much unless that you use the most recent versions, newer additional instruction. Otherwise, if you just use 3.2, 3.4, I think any version should work in a similar way, except for the performance. Is that okay?
Yeah, that's okay. Thank you.
Any other question? So this week is more lower level, and I don't think there are too much theory behind it. No, it's just implementation, okay? So the suggestion is just you figure this one out by running it, okay? We do give you a not very, very example. You just follow the slices example to run it. That's good enough. And there are sample code you can download from our Code Shell website, and you can run those code, okay? Other than that, I think this one do not have the deep theory like lecture or parser. No, this one no theory, just running the code. Okay. Any question?
No.
Okay, no question. That's it for the day. Okay.
Thank you.
Bye now. Bye now. Bye bye.